June 1944. The Allies stood poised on the edge of a continent, ready for the ultimate leap. Millions of soldiers, thousands of tanks, millions of tons of ammunition. Yet, one problem threatened to turn triumph into a bloody stalemate: logistics. How to supply such an army on hostile shores? The answer was as audacious as it was ingenious. The Allies decided not to capture a port. They decided to build one. And not just build it, but bring it with them. This is the story of the Mulberry Harbours, the colossal, floating ports that changed the course of the war. But how do you build an entire port, capable of withstanding the Atlantic storms, in just a few days? It began with an idea. The very fate of Operation Overlord hung precariously on a logistical knife edge. Allied planners understood that the success of the D-Day landings depended not merely on getting troops ashore, but on a sustained, overwhelming influx of supplies and material to fuel a rapid breakout from the beaches before German counterattacks could materialize. The scale of this requirement was staggering. Within the first 3 months alone, the invasion demanded the landing of over 2.5 million men, an incredible 500,000 vehicles, and upwards of 4 million tons of essential supplies: fuel, ammunition, medical equipment, and engineering resources. Conventional military doctrine dictated that such a massive logistical tale could only be supported by the rapid capture and utilization of a major, deep-water port. Strategically, the closest viable port was Cherbourg, approximately 60 miles northwest of the primary landing zones. However, intelligence reports were stark. German defenses around established ports were formidable, meticulously fortified, and any port they lost would be systematically and ruthlessly destroyed by demolition charges, a scorched-earth tactic proven repeatedly throughout the war. Waiting weeks, or even days, for a port to be seized, cleared of mines, and painstakingly repaired was simply not an option. The Allied invasion force would quickly outrun its supply lines, risking catastrophic failure and potential annihilation. The very viability of liberating Europe, therefore, demanded an audacious, seemingly impossible solution: a port that could be constructed, transported, and deployed, effectively conjuring essential infrastructure where none existed. The very fate of Operation Overlord hung precariously on a logistical knife edge. Allied planners understood that the success of the D-Day landings depended not merely on getting troops ashore, but on a sustained, overwhelming influx of supplies and material to fuel a rapid breakout from the beaches before German counterattacks could materialize. The scale of this requirement was staggering. Within the first 3 months alone, the invasion demanded the landing of over 2.5 million men, an incredible 500,000 vehicles, and upwards of 4 million tons of essential supplies: fuel, ammunition, medical equipment, and engineering resources. Conventional military doctrine dictated that such a massive logistical tale could only be supported by the rapid capture and utilization of a major, deep-water port. Strategically, the closest viable port was Cherbourg, approximately 60 miles northwest of the primary landing zones. However, intelligence reports were stark. German defenses around established ports were formidable, meticulously fortified, and any port they lost would be systematically and ruthlessly destroyed by demolition charges, a scorched-earth tactic proven repeatedly throughout the war. Waiting weeks, or even days, for a port to be seized, cleared of mines, and painstakingly repaired was simply not an option. The Allied invasion force would quickly outrun its supply lines, risking catastrophic failure and potential annihilation. The very viability of liberating Europe, therefore, demanded an audacious, seemingly impossible solution: a port that could be constructed, transported, and deployed, effectively conjuring essential infrastructure where none existed. As was often the case during moments of profound crisis, the solution emerged not solely from the rigid minds of military strategists, but from the indomitable imagination of Prime Minister Winston Churchill. As early as May 30, 1942, a full 2 years before D-Day, Churchill, with characteristic foresight, presciently identified the looming logistical chasm that threatened to cripple any cross-channel invasion. Frustrated by the conventional limitations of existing port infrastructure and the inevitable destruction, he penned a now legendary memorandum to his chiefs of staff, his words cutting through bureaucratic caution. They must be artificial harbors, as easily built as a child's toy and as seaworthy as a ship. He pressed for a definitive solution, specifically emphasizing the absolute necessity of two critical components: breakwaters to shelter vessels from the unpredictable channel weather, and robust piers for efficient offloading. Initially, such a concept was met with widespread skepticism. The very notion of fabricating two massive, fully functional ports, each capable of handling the heaviest Allied shipping, then towing them across one of the world's most tempestuous sea lanes, the English Channel, and assembling them under potential enemy fire, seemed to many like pure fantasy. Yet, it was precisely this impossible vision, fueled by the existential urgency of wartime, that compelled Britain's most innovative engineers, led by figures such as Professor John D. Bernal and Vice Admiral John Hughes Hallett, to transform a wild idea into a meticulously planned, tangible, and ultimately game-changing reality. The inherent genius of the Mulberry Harbours lay not in a single, monolithic structure, but in its revolutionary modular design, an ingenious, interlocking system comprised of three distinct, yet perfectly integrated, components. Each piece represented a marvel of engineering, purpose-built to conquer the unique and formidable challenges posed by the English Channel and the unforgiving Normandy coast. Firstly, the breakwaters. These formed the crucial outer, defensive shield, indispensable for creating a calm, navigable harbor basin amidst the notoriously rough and unpredictable waters of the English Channel. This protective barrier was comprised of two complementary types: the immediate, albeit temporary, wave dampeners formed by strategically scuttled merchant ships and old warships, codenamed gooseberries, and the truly colossal, hollow reinforced concrete structures known as Phoenix Caissons. These Phoenix Caissons were the leviathans of the project, meticulously designed to be towed and then precisely sunk in a predetermined formation, creating a formidable, semi-permanent, and storm-resistant wall against the relentless forces of the waves. Secondly, the pierheads, or spud piers. These constituted the vital, elevated platforms from which ships would offload their precious cargo. The fundamental engineering challenge here was to accommodate Normandy's aggressive tidal range, which could fluctuate by as much as 20 feet, 6 meters. Conventional fixed piers were simply unusable under such conditions. The solution was a stroke of mechanical brilliance. The spud piers were designed as floating platforms, each equipped with massive, adjustable steel legs, or spuds. These spuds could be hydraulically raised or lowered, anchoring the pierhead firmly to the seabed while simultaneously allowing the entire platform itself to rise and fall seamlessly with the tide. This ensured continuous offloading operations, irrespective of the fluctuating sea level, guaranteeing a vital, uninterrupted logistical flow. Thirdly, the roadways, whale, and supporting pontoons, beetles connecting these ingenious tidal-compensating pierheads to the actual shoreline was an equally innovative floating roadway system. The roadways, codenamed Whale, consisted of numerous interlocking sections of robust steel bridging, each meticulously engineered for flexibility and strength. These whale sections were, in turn, supported by buoyant, resilient steel pontoons, affectionately known to the engineers as beetles. This entire floating highway system allowed a continuous, unbroken stream of trucks, jeeps, and heavy equipment to drive directly off the ships, traverse the pierheads, proceed along the flexible floating bridges, and finally drive straight onto the invasion beaches. This unprecedented infrastructure bypassed any dependency on fixed port facilities and, crucially, rendered irrelevant the enemy's efforts at port demolition. The Phoenix Caissons represented one of the most remarkable and technically demanding feats of civil engineering undertaken during the entirety of World War II. These were not merely rudimentary blocks of concrete, They were precisely engineered, hollow, cellular structures of immense scale, ranging dramatically in length from 200 feet, 60 meters, for the smallest units to an astounding 600 feet, 180 meters, for the largest, with individual units weighing up to an astonishing 6,000 tons. Their construction was a testament to the colossal industrial might and the imperative for absolute operational secrecy in wartime Britain. These behemoths were built in deep, often hastily adapted dry docks, disused quarries, and specially excavated basins located discreetly along the length of the British coastline, from the bustling Thames estuary to the quieter inlets around Southampton and the Firth of Clyde. Their very existence was a closely guarded secret, frequently camouflaged to deceive German aerial reconnaissance. Each caisson was an intricate vessel, equipped with a series of precisely controlled internal chambers and floodable compartments. This intricate design allowed them to be floated out of their construction sites, meticulously towed across the turbulent English Channel like monstrous, lumbering barges, and then, at a precise moment over their designated seabed location, rapidly flooded through controlled valves to sink vertically and permanently onto the seabed, thus forming the impenetrable, stable outer breakwaters of the artificial harbors. They were designed not just to withstand the raw power of the ocean, but to endure years of relentless operational use. The sheer scale of manufacturing required to bring the Mulberry Harbours into existence was an extraordinary national undertaking, demanding unprecedented levels of industrial coordination and output under the absolute veil of wartime secrecy. Nearly 200 major British contractors, encompassing everything from traditional shipbuilders and steel fabricators to civil engineering firms and concrete specialists, were enlisted. This effort mobilized tens of thousands of skilled and unskilled laborers across the length and breadth of the United Kingdom, often working around the clock in shift. To mitigate the risk of concentrated bombing by the Luftwaffe, production was deliberately decentralized. Steel for the intricate whale roadways was fabricated in multiple, dispersed specialized yards, while the colossal concrete Phoenix caissons were constructed in over a dozen different coastal locations, a crucial military decision designed to avoid presenting a single, vulnerable target to German aerial reconnaissance. By the eve of the D-Day invasion, the Allies had manufactured and meticulously stockpiled an astonishing 1.5 million tons of concrete and steel components. This staggering inventory included 146 Phoenix caissons, over 10 miles of whale roadways, 24 spud pierheads, and 200 beetle pontoons. This massive, coordinated industrial mobilization, a silent army working tirelessly behind the scenes, was an absolutely essential prelude to the success of the largest military invasion in history, demonstrating Britain's unparalleled capacity to transform its entire industrial base into a giant, meticulously synchronized war machine. The moment the prefabricated components were ready to leave British waters, the operation entered its second, most precarious phase, the mass transit across the English Channel. Dubbed the slowest invasion fleet in history, this armada comprised over 300 individual tows, requiring the dedication of hundreds of tugboats, many of which were small, civilian vessels commandeered for the war effort. The average transit speed was agonizingly slow, rarely exceeding 4 knots, about 4.6 miles per hour. This vulnerability was compounded by the sheer size and unwieldiness of the cargo. The massive, hollow Phoenix caissons, each weighing thousands of tons and sitting precariously in the water, and the segmented, fragile whale roadways were highly exposed to both the persistent threat of German naval resistance and the brutal, unpredictable volatility of Channel weather. Route planning was a monumental intelligence effort. Corridors were meticulously cleared of mines by Royal Navy sweepers, and the entire logistical snake was continuously shielded by fighter and reconnaissance aircraft from Allied air forces, tasked with repelling any incursions by German E-boats, Schnellboot, or lurking U-boats. The safe arrival of every single section was paramount, as the loss of even a few core components, a key pierhead or a series of caissons, could compromise the structural integrity and tidal capacity of the entire finished harbor. This long, arduous tow was a high-stakes, nerve-wracking relay race against time, demonstrating the unwavering commitment of the often unseen maritime crews who delivered the foundations of the invasion. The Allied logistical strategy was predicated on redundancy and scale, the deployment of 2 full-sized artificial harbors. Mulberry was designated for the American sector at Omaha Beach, Vierville-sur-Mer, strategically placed to support the rapid westward drive of the U.S. First Army towards Cherbourg. Mulberry B was allocated to the British-Canadian sector at Gold Beach, near the coastal town of Arromanches. The installation process commenced immediately upon arrival, transforming the invasion beaches into complex construction site. Expert teams from the Royal Navy and the Royal Engineers, operating under challenging conditions often punctuated by residual enemy shelling, orchestrated the precise sinking of the Phoenix caissons using controlled flooding valves to establish the secure outer basin walls. The floating spud pierheads were anchored, and the miles of whale roadways were carefully bolted together, connecting the offshore platforms to the beach. This assembly sequence was a triumph of industrial standardization. Hundreds of separate, complex components, manufactured in isolation across Britain, were designed to interlock perfectly and function as a seamless, integrated unit. Within the first 2 weeks, the harbors began to emerge from the sea, providing clear evidence that the Allied logistical promise, the ability to sustain the invasion, was being fulfilled. 12 days after the successful landings, on June 19, 1944, the entire Mulberry project was blindsided by a catastrophic force of nature. An unprecedented, violent storm, later recorded as the worst to strike the Normandy coast in 4 decades, raged across the channel for 4 relentless days, forcing all unloading operations to a standstill. The consequences for the fragile, exposed artificial structures were immediate and devastating. Mulberry at Omaha Beach, situated on a more exposed section of the coastline, suffered a total catastrophic failure. The fierce waves shattered the whale roadways, tore the massive Phoenix caissons from their temporary moorings, and the entire harbor structure was rendered completely unusable and irreparable. It was a massive, irreplaceable loss to the American supply schedule. However, Mulberry B at Arromanches, positioned fortuitously in a slightly more sheltered natural bay, proved more resilient. Though heavily battered and severely damaged, with sections of its roadways breaking away, it held together. Royal Engineers and Navy personnel worked heroically, risking their lives in the mountainous waves, to salvage and stabilize the remaining sections. The storm exposed the absolute limits and inherent vulnerability of the ingenious design, yet the survival and swift repair of B proved the fundamental, life-saving soundness of the underlying engineering concept. The destruction of Mulberry A instantly elevated the remaining harbor, Mulberry B at Arromanches, to the single most critical supply point for the entire Allied operation. Affectionately christened Port Winston by the grateful troops, the harbor achieved near-legendary status as the ultimate logistical bottleneck breaker. Despite the severe damage from the storm and operating at only a fraction of its originally intended dual harbor capacity, its performance was staggering and decisive. For over 100 days, the crucial period before the permanent deep-water ports of Cherbourg and later Antwerp could be fully secured, cleared, and repaired, Port Winston maintained the momentum of the Allied advance. Its continuously operating floating piers and resilient roadways enabled the non-stop offloading of over 2.5 million men, a crucial 500,000 vehicles, and a colossal total of 4 million tons of essential supplies. This sustained, high-volume logistical lifeline was the single most important non-combat factor, preventing the Allied spearhead from grinding to a halt in the face of stiff German resistance, ultimately allowing General Patton's Third Army to execute its decisive breakthrough and race across France. The operation's success proved that the Allied logistical genius was fully capable of overcoming the German strategy of defensive port demolition. Today, the magnitude and engineering miracle of the Mulberry Harbours is perhaps best comprehended by visiting the historic coast of Arromanches. The site of the successfully operated Mulberry B remains an extraordinary, visible monument to ingenuity under the most extreme pressure. Even over 80 years after the invasion, at low tide, dozens of the massive, steel-reinforced concrete Phoenix caissons are still clearly visible, standing resolute and defiant against the Channel waves, a silent, enduring testament to the logistical brilliance of the Allied effort. This ambitious project not only cemented the Allied victory in the Battle of Normandy in 1944 but also demonstrated a revolutionary, proven approach to modular, rapid deployment infrastructure that profoundly influenced post-war civil and military engineering, particularly in areas of tidal and offshore construction worldwide. The Mulberry Harbours remain a compelling symbol, proving that the true deciding factor in modern warfare often lies not solely in the battlefield engagement, but in the unwavering, uncompromising genius of military logistics and engineering innovation.